Hello, everyone, and welcome to today's webinar. My name is Mara Johnson. I'm the Communications Coordinator here at the UNH Interoperability Lab. I'll be serving as your moderator for today. On today's webinar, TR398 Issue 2 Explained, we will discuss the Broadband Forum's TR398 Issue 2, the IOL test setup for this testing, and what it means for wireless performance. We'll also have a sneak peek into some results which are coming out of TR398 testing thus far. Let me go ahead and introduce our presenters today. From UNH-IOL, we have Lincoln Lavoie, Principal Engineer in Broadband Technologies at the UNH-IOL. In his role, he is responsible for the technical management of the Broadband Access Technology Grounds. In addition, Lincoln is the Broadband Forum Technical Chair and participates and has over 20 years of experience in testing broadband technologies. Also joining us from Verizon is Mike Talbert. Mike has over 20 years of experience working specifically with customer premise equipment. He joined Verizon in 2005 and focuses on architecture with Wi-Fi and service assurance as additional fields of interest. In his current position as Associate Fellow, Mike is focused on defining next generation home architecture and bringing the next generation architecture to the Broadband Forum, driving additions and changes to the existing standards. After our presentation, we do have a live Q&A. We encourage you to submit your questions at any time during this webinar. We will address them at the end. You have the Q&A section on your screens. We would also love to hear from you on social media as well. Please join us on our social channels, #UNH-IOL, #Wi-Fi webinar. Just a quick reminder, there will be a recorded version of today's webinar available for download. We'll also have the slides up on our website, and I'll make sure that everyone who has registered and attended today will get that link. So we're really excited to have everyone join us today. Thanks again for joining us. Let's get started. And what I'm going to do is actually pass it off to Mike.
Thank you very much, Mara, for that fantastic introduction. Welcome, everyone. Good morning, good day, good afternoon, good evening, depending on which geographic part of the world you are at. Let's take a quick look at agenda. And, probably the most important thing to understand is today, our consumers, is it Wi-Fi? Is it the internet? Is it broadband? Is it broadband or Wi-Fi? This has started to become synonymous. People, hey, my internet isn't working. Whether it's Wi-Fi or whatever, it's really been defined as, it's started to be synergistic across this. We're going to talk a little bit about TR398 and what issue 2 is and what it covers, and then how to, really look at repeatable testing using TR398. Additionally, we're going to look at some of the first results out of our testing. Lincoln, if you can move to the next slide. So some of the experience killers that we're aware of and that we can take advantage or start to address are low signal type of issues. Obviously, when you have low battery in some of your mobile devices, it very much impacts your ability to get onto Wi-Fi or get a good, robust Wi-Fi experience. Some of the things we can address are things like battery. But TR398 is really looking at, the things we can address and how to better understand customer experience. Next slide, please. How important is customer experience? It is really the key into subscriber revenue. If our subscribers have a great quality of experience, they're happy. If they don't have a great experience, then we have some challenges. Some of the things we hear back from our subscribers, it needs to be easy. It should be convenient. I shouldn't have to worry about it. It should just work. These are some of the things we hear back from our subscribers, which is really what drove some of the TR398 work effort that we're going to share with you in some of the forward-facing slides. The other thing that's really important is that service providers really want better tools to understand how well that quality of experience is being edified by our subscribers. We'll talk about that as we get a little bit through some of the additional slides. Next, please. This information came down to us from Omdia's service provider survey that was conducted this year from the Connected Home division of the Broadband Forum. What I'm trying to share with you here is that look at how important Wi-Fi is and or Wi-Fi related issues are. Configuration setup, Wi-Fi performance. When we look at things like broadband latency and jitter, those are parametrics that sit behind Wi-Fi. Poor audio or video conference performance, also impacted by Wi-Fi. Broadband service setup, also a big piece of Wi-Fi. Poor application service performance, again, in today's connected environment, Wi-Fi is that common theme of really what's impacting the quality of experience for our subscribers. Next slide, please. So, the complexity of the home. Oh my gosh, look at the explosion of devices that are coming into our home these days. A number of years ago, our common number of devices was, average 8 across the country. Last year we were between 12 to 16. We see today that the number of devices in the home continues to drive northbound, and it's not uncommon to see 40, 50, reaching up to 100 devices in some of our homes today. What does that mean to us? Well, it means that, getting signal and getting good signal to those devices is going to be key in its importance to really ensure that quality of experience. We see the addition of 6 gigahertz Wi-Fi that's going to drive some additional bandwidth into the home, but we also see the existing 2.4 and 5 gigahertz Wi-Fi that's really driving the ecosystem today. And there's a lot of contention in those areas. Some of these homes are larger homes. Some of these homes have material constrictions like brick, some of the older drywall that will impact Wi-Fi performance. So understanding that all and understanding the complexity is really going to drive us into why we believe TR398 is an important solution to understanding performance across the home. Those Wi-Fi access points today, whether they're connected via Wi-Fi or whether they're connected via MoCA or Ethernet or G.hn, really defines the architecture and topology of the home. Again, not that important to our subscribers. Most importantly is how do we get that Wi-Fi signal to our subscribers and make sure that it is able to support the quality of experience that they're expecting. With that, I'm going to turn it over to Lincoln and really get into some of the nitty-gritty details about TR398, what it's all about, and what it means moving forward. Lincoln, over to you.
Thanks, Mike, and good day to everyone. And I think that kind of sets the stage really well for diving right into, in a nutshell, what is, TR398. This really is one of the first industry adopted test plans to evaluate the performance of devices. So when we're looking at like the device under test being those access point devices, the focus really was there because that's what's in the scope or the control of the service providers that have been instrumental in driving the development of this testing. And they're looking to those access point devices as carrier grade devices being something that they can push into their deployments to really impact that subscriber experience, that quality of experience that they're driving at. And I think everybody has really internalized in the broadband community, the importance of that customer experience and how that translates to, happy customers, less churn, and then ultimately kind of that bottom line, as it were, for their business. One of the things that's unique about the TR398 test plan is it's one of the first places that we've really seen the industry work together to develop an absolute set of performance metrics, right? And one of the things that drives is allowing for direct comparisons between devices meeting, that bar of pass, fail, et cetera, and stuff like that. There's, a strong focus within that methodology around developing testing that ensures repeatability, allows, comparison run to run, device to device, lab to lab. All those things really become key for how you actually can evaluate these carrier grade devices that are moving into the fields and being utilized by the service providers. So if we look towards, what is the actual test coverage that are brought forth in TR398, it really shouldn't be any huge surprise to folks, what is actually kind of the focus here in terms of it, it's got the kind of basics of RF performance. Obviously we're looking to coverage. Mike mentioned that whole home scenario, making sure that you can do that. But then also you have things like capacity and bandwidth. So looking at how the Wi-Fi systems perform, when they start getting loaded up, either in terms of number of clients or the total amount of bandwidth. And then obviously instrumental part of that carrier grade piece is the stability or the robustness of that Wi-Fi, right? So like, what does that link look like over a longer course of time? How well does it perform over time, et cetera? Does it fall over in the middle of the night? Does it fall over, 4 hours into a movie or into, a binge watching of a series? Any of those things would obviously crush the consumer experience. And then last but not least, as we're pushing forward towards like multiple APs and the roaming scenarios, as these Wi-Fi deployments become more complex. If we look at like what actually is included here from kind of the technology perspective, we're including the Wi-Fi 5, the Wi-Fi 6 now. So that's 802.11n, AC, AX. And it's also focusing on the two spatial streams. Why? Because that's where a lot of the consumer experience is today, right? So like your small mobile devices, your tablets, your streaming devices, those are two spatial stream devices. And so the testing that's included herein is really aimed at mimicking that performance and an evaluation of that performance, rather than generating what might be, marketing numbers for absolute or peak performance that you could pull out of the latest device, using either 4 spatial streams or even, some of the hybrid gaming systems that might have something like 8 spatial streams, because that's just not realistic to kind of those end consumer devices that we're aiming at the quality of experience for right this second. And then last but not least, I did mention it already, but it is that absolute performance metrics requirement, and that drives the ability to actually have pass-fail outcomes of the system, right? So overall, if we drive down to the 50,000-foot view of how do you look at a test plan here today, the test plan from TR398 doesn't focus on specific test and measurement equipment. It's not going to say item ABC from manufacturer Y, but it focuses on describing the actual requirement set for the test environment that it creates, and then that is part of what we do for the repeatability of it, right? So it does specify that clean air environment, how much ingress RF or noise from just the environment at large is acceptable within that test environment. And then it also includes definition of things like station, how you control the stations for the system, how do you establish that RF path, what does that RF path constraints look like. Most of what we'll get into in 398 in terms of establishing that RF path does provide some definition of the equations there and the free space as they would relate to a simple antenna and the expectations there, and that's used as part of this to establish that baseline. It does also talk a little bit about the requirements and the configuration of the device under test, and the device under test being, unmodified in its deployment configuration. So we're not looking at like a cabled RF environment. We're not looking at, disabling certain parts of the device or disabling certain radios, right? So like that does couple into the testing. And then it also does address some things like how is the device configured in terms of what RF path or RF channels are being used for each of the wireless technologies. And then it, because it is being developed as part of, a global community, we do also account for, the different regulatory power allowances that you would see in the devices. So there are going to be specific requirements that are going to get tuned for if you're, applicable to the European regulatory zone versus like the North American or the US ones. And those are all taken into account. It does fall to the stations to then drive some of that connectivity in terms of the technology that's being focused for this scenario. If we're going back to the device under test being kind of opened up in its deployment configuration, it's probably going to support all of those wireless technologies, that are in and out of scope of 398. But the control of the station as part of the definition of the test allows us to actually control and limit that connection to the area of interest for the specific test scenario. So if that was the 50,000 foot view, then, let's kind of dive down here to like the 10,000 foot view. Looking at how we're actually implementing those requirements here at the lab. We have a test bed built up on Octoscope's personal test bed, as they brand it. It's actually built in our lab with 3 individual RF isolation chambers. So these are smaller chambers. We'll see a picture coming up of what they actually look like in real life. Each of those chambers, has a controlled RF path between the device. So if I was to kind of highlight here on the slides, the little boxes that we're kind of showing as what would be called like a quad attenuator or a programmable attenuator, allows us to essentially establish that RF path between the devices that would be either in this chamber or the PAL6 device and the device under test here located in the bottom chamber. As I've highlighted before, the DUT is actually in its original shipping configuration that it would go to the subscriber site as, right? And so that means that it has both its antennas there, and it is not being cabled into the test environment. So this is a little different of approach from what you might see for other RF environments, where the RF testing goes fully cabled from the PCB board that's in the device that's actually being tested straight on out to the test and measurement equipment to allow you to completely control that path. And while that's good, and obviously necessary for some types of testing, it also has the effect of it wouldn't actually take into account the design of the device under test, its antenna designs, the placement of those antennas on the device, and it would prevent you from being able to do things like looking at the device's spatial consistency or how it performs as we kind of rotate it through. So we're doing that RF path inside the chamber. We're using near field antennas here to essentially kind of couple that air gap to the device under test before we get into that cabled environment between the chambers. I mentioned just really quickly that PAL device is actually where we're emulating the stations, right? And so the PAL6 devices support everything from 802.11 ABGN all the way on up to the newest 802.11ax, and can emulate a number of stations all at the same time. So that way we can load up the device with the number of wireless stations that it sees connecting to it. And then last but not least, we're actually controlling all of that test environment through our test automation software, Test Sentinel. This ensures that the testing is repeatable, that the same steps are taking every single time, the same measurements are taking every single time. It also allows us to store all of the results directly into our test database. We use that as part of our reporting process. And then it also gives us an opportunity to look back at like historical data. So we can look back at how a device did with like a previous firmware version or a different tweak or a different configuration if we're exploring that space with any of the customers as well, right? And so like it gives you a lot of flexibility, but it also gives you a lot of control and good definition to the testing. So looking at the actual devices that are building up this test bed, right? So like the image on the left is where you'd actually see for the device under test in that chamber. It's got those near field antennas that I mentioned. One thing I would call out is you can definitely see that there's antennas on all 3 of the walls there. So kind of the back, left, and right walls. And so that actually meets the requirements that are outlined in 398 for some of the MU-MIMO testing, ensuring that you have some level of like spatial divergence that you have for the system, that you have stations appearing to be coming from different kind of incident angles with different RF paths. And you'll also get the different RF path as it couples into the antennas inside the device. We do have that platter that you see there in the bottom. That's the turntable. I don't think I talked to that completely on the other page, but part of the testing does require that you'd actually change the positioning of the device. And so having that as something that's a controllable piece actually lets us move everything into position without actually having to open or manually reposition the device under test. Again, it's all part of that automation, so it drives that level of repeatability, that level of control. We do have that camera there in the upper left. It's always good to keep an eye on what's going on in the box, especially with the cables kind of flying around to the DUT and stuff like that. You want to make sure stuff isn't getting caught, that it's rotating, you can see it without actually impacting the testing, opening the chamber, or anything like that. On the right-hand side, you've got the full stack. So that's, the entire set of those 3 boxes that I mentioned. You can see it's a fairly tall system. You've got all that blue cabling on the outside. That's your RF path between those boxes. So that's the actual real cabling part of it to those near field antennas coming through the box. And then also the silver boxes are the attenuators, or those programmable devices that let us kind of establish that RF path. So if I was going to, continue kind of the analogy of the altitude there, if we were at 10,000 feet, now we're at 1,000 feet, right? So we're down one at a closer look at what we actually have here. So, and overall, this is going to be kind of providing the coverage for the majority of the test cases defined within TR398. We have, the PAL-6. That device is really emulating the stations. We're controlling that to be basically one or more device. We've got that programmable attenuator. And then we've got the box with the turntable and those near field antennas. And then last but not least, we bring the device under test right into that chamber. So with the turntable and the programmable attenuators, that's actually kind of building up that RF test scenario, or what we would describe as the scenario that we're under test. So Mike mentioned before, you've got houses that, might have different layouts. They may be larger, they may be smaller, they may have different building materials. All of that actually just factors into, from the wireless perspective, kind of what you end up with in terms of that total, environment RF wise between the station and the device. You'll see, more or less attenuation. You may see a little bit more or a little bit less spatial divergence. You may be, kind of incident on the device under test, or the AP, from a different angle. But all of those things together kind of couple up to what that RF environment looks like. And so what we have here is basically the ability to control that environment as much as possible. And then, through that control, we're obviously automating everything, again, through Test Sentinel, so that way we're actually able to kind of drive that level of repeatability that is necessary for it. And then, as I mentioned, this is probably the majority of the actual TR398 cases. Obviously, the stack with all the equipment gives you all of them, and there are cases that are going to require devices, where you have one station at one distance and another station at a different distance. So you need 2 of those quad attenuators, or 3 of the quad attenuators, to kind of offset those distances. But again, if I was to distill everything down, this is probably your base case, right? So this is the case that's easiest to really understand what's actually going on in the testing. So it's impossible to actually talk about testing without actually diving into what some of the gremlins are, right? You always kind of need to understand what's going to impact your environment, what's going to actually cause you the headaches as you're doing the testing, right? And so some of the things that we really, run into, or have run into, or have had the growing pains as we've been implementing TR398 testing over the last several years, first with issue 1 and now with issue 2, really accounting for that RF path and actually understanding what is that RF path in your T&M gear. So it's not just a function of that air gap with the near field antennas. Obviously, you need to characterize that, but also, characterizing the attenuators themselves, the cables themselves, anywhere you've got either a power splitter or a coupler or anything like that, all of those systems actually impact the test as you run it. And you need to really be able to understand those so that you can essentially establish the baseline for your device. Now, TR398, I didn't get into it in a previous slide, but it does actually outline specifically what would be kind of that RF base case, which is essentially, kind of a trying to get to what would be about a 2 meter free space loss, right? So if it was implemented in the ideal world, you would essentially have the station 2 meters of open, clean air, and then the device under test. So what we're trying to get in our test setup is essentially that in our well-known RF path. The other thing that you definitely have to be aware of is the station impacts on it. So, whether it's T&M gear or a real station, those things are typically built from devices as they are in the field. They've got real chipsets in them. Those chipsets actually have firmware and stuff like that. That can actually impact your testing as well. We have definitely seen the possibility of that increasing the closer you get to the leading edge on the technology. So, if you're up there testing, 802.11ax, or even now moving towards like the 6 gigahertz AX, the probability you're going to see impacts from the differing chipsets, the differing firmware kind of increases. Now, obviously that mimics the real world scenario, so it's not necessarily a bad thing, but it's one of the things you just need to be aware of. The device positions relative to the near field antenna is also critical. So you've got to, especially if you've got either smaller or larger devices as they fill into that chamber space, whether you need to set it up on a small pedestal, if it's a device that tends to be kind of small or thin, as some of the smaller AP repeater type devices might be, or the pucks, as you've seen in the field, or if they're kind of the larger gateway devices, just where they are in those near field antenna space. And then minding those cables as things are moving around in the chambers and stuff like that. You obviously don't want those cables then rubbing up against your near field antenna, since that will impinge on the antenna's performance, and it's going to cause like your results to essentially kind of skew one way or the other in terms of the overall RF performance. If you're implementing the traffic on something like a generic CPU or generic COTS OS or something like that, be aware that that you can have impacts on that from the TCP stack, how it's working, whether the CPU is doing other things. So it really just depends on your specific implementation, but knowing the layout of that environment and its impacts there are also somewhat critical. And then last but not least, I know I've harped on automation kind of throughout this, but it really is key to the repeatability. Us humans are bad at repeatable tasks. Every time I've given this presentation here, I don't know if I've said the same thing twice, and we just don't work that way as human beings, but software and code and automation does. And so that way we can kind of ensure that the same measurements are taken, whether it's the same amount of time between a measurement or the settings that are used or exactly the steps that were taken. Having that automation ensures and drives that repeatability more than anything else. So I know everybody's been kind of dying to see where we're at results-wise, right? And so I wanted to pull up and focus here in a little bit on some of the new things that are coming with issue 2 of TR398. So that a lot of the big thing added there, aka Wi-Fi 6, also known as 802.11ax, is included in this test plan with those absolute metrics. So TR398 does define those absolute metrics. You can see the blue and the gray, the blue and the brown lines there, actually defining what are the requirements for the uplink, downlink on the devices. And then you can see the other 2 measurement lines above that are how this device actually performed. Now, this is one of the devices we've run through in our lab. It is an actual carrier grade device. And so you can see it's easily meeting those carrier grade requirements. So if we remember what is kind of the origin of TR398 testing, coming from the operator community and the service provider community to basically tune these devices to the needs of their deployments, we can see that the carrier grade devices are going to easily kind of meet those requirements because they're being purpose built essentially to that level there. One of the other things that's interesting to pull out from these first set of requirements here, if we look over on the right-hand side at the 802.11ax on the 5 gigahertz band, we can actually see that some of those throughputs are pushing well above, 900 megabits or so, actually getting close to 940, 950 megabits per second. And what that actually is the TCP throughput there as specified by the TR398 measurement. Well, you're actually starting to push close to that theoretical maximum throughput at that level, the layer 4 there, of the 1 gigabit Ethernet connection that's coming in and out of that duct. And so you're actually going to see that to start being one of the determining factors in some of the testing as we move forward in the technologies, right? So like, this is for 2 spatial streams. If we were to increase the spatial stream count, we're going to actually see the wireless bandwidth go up, but you're still going to have that limited backhaul case. So that's something, that as we to further develop the TR398 testing is going to have to get taken into account and will be taken into account. So I'm sorry for the eye chart on this one. I couldn't really think of a great way to do this graphically, but I wanted to get in this other kind of new test case that we've got in the issue 2 testing with essentially the dual band modes, right? So dual band is looking at how the systems perform when they're doing 2.4 and 5 gigahertz traffic at the same time. Now that traffic might be downlink and downlink, uplink and downlink on each of those scenarios. So we're not doing bidirectional on each of those. It's still a unidirectional traffic. But it's using the 2.4 and the 5 gigahertz at the same time. And then we're looking at those essentially 4 scenarios at 3 different attenuations or 3 different distances or lengths. And so that's, essentially short, medium, long there as established by the attenuation marks that are showing there. And we're seeing that overall, again, the carrier grade devices are hitting all of those marks without any issue whatsoever. For that. So again, apologies for the eye chart. I didn't have a great way of showing this, but I think it's interesting to actually kind of point out this is one of the newer tests coming from TR398 issue 2. And then as one more kind of test, this isn't new to issue 2, but again, looking at like the 802.11ax requirements that are defined is the spatial consistency. So again, speaking towards how these devices perform in the actual homes, real world scenario, you'll have people coming at a device from different angles as the coverage throughout that house. So what we have here is, again, looking at essentially 12 different incident angles of the device relative to the near field antennas that are essentially coupling in that station to the device under test. We're looking at that at 12 different angles, and then again at 3 different lengths. So a little bit of the eye chart on the left-hand side there showing all of that. And then on the right, we actually broke that out to a polar plot showing the longest of the distances. So that 35 dB of attenuation case, that actually is driving towards about 100 meter of free space when you account for the 2 meter air gap kind of baseline that's built into the test setup. So you can see kind of that overall performance and that consistency around that. Now, the requirements as they are outlined in TR398 actually does define, a minimum bar for each of these. I think it is 400 megs if I was to remember off the top of my head for the 35 dB case of 802.11ax. So you're looking for each of these numbers to essentially be above that 400 megabit per second requirement. And then you're also looking at what is the consistency or the variation around those 12 measurement points. And both of those things actually couple into the metrics. Now, if I said 400 meg, you're probably wondering what's going on if this is passed, but we still have something just below it. One of the things that issue 2 did add and account for is there is always going to be a little bit of probabilistic variation in your testing results overall. You can make the same measurement, and you might get a few percentage points difference on that measurement. And so we do allow for some measurement points to be thrown out. I think it's essentially 1 measurement point from each of the attenuations for the spatial consistency, but that measurement point still does couple into the kind of total variation. And the total variation is doing, exactly what it says. It's looking for essentially those soft spots in a device. And so you could actually see a soft spot, here where you're going to see that device kind of dropping down in its RF performance at one of its specific orientations. And one of the things we always kind of look at as we're looking at the data and kind of validating our stuff is, do we see that soft spot kind of persist through the different attenuations, right? And so it's really hard to see over here at the short attenuation, 10 dB, that device is kind of performing where you'd expect it to be. But when you start to increase those attenuations, you do actually start to see that soft spot kind of start to materialize with some slightly lower rates. And then out at the furthest distance, you can definitely see that spot there appear. So it's just one way that you always kind of need to look at those results and understand, the measurements you're making and how do you get that level of consistency. So then where are we heading to next? The Wi-Fi technologies are always going to continue to evolve. The deployments that are going to continue to evolve how they use those technologies. So service providers are already starting to look towards some of the newer technologies. They're talking about what's going to happen with 6 gigahertz, for example, as well as things like rolling out multiple APs, and automation or closed loop automation of those APs in the home. Again, the whole goal is driving that customer experience up. So as such, 398 development is going to continue. We're going to continue to add testing to it. We actually kicked that work off this past quarter, even at the very recent Broadband Forum meeting. So that's actually, rolling out and progressing forward. And we've got a whole list of scenarios that'll be going there. Some of the key things, like I mentioned, there's 6 gigahertz, obviously the key topic. But if you think about multiple APs and using wireless backhaul, that's starting to drive some interest of actually setting some metrics on, the higher spatial stream count, because you may actually see, those AP and the mesh systems using 3 or 4 spatial streams between the access points as their backhaul, while the subscriber links continue to kind of be those 2 spatial stream devices. But that's going to start to mean that 4 spatial stream device performance starts to become a critical factor in broadband deployments. And so 398 will obviously be keeping up with that overall. And then we also have, testing underway for issue 2, which did, publish earlier this month from the forum, to get the first, BBF 398 grade devices done and completed. So that those devices are rolling forward with, the lab testing now, and we'll be entering the field. If I was to crystal ball it, probably, later Q2, around the summer timeframe here in the Northern Hemisphere, as it were. So with that, I believe that ties us up onto all of our slides here, and we wanted to open it up to questions and answers, as it were.
Awesome. Thank you so much, Lincoln and Mike. You guys really did cover a lot of great information. It's really exciting to kind of see where the future of wireless testing is headed. We did get some questions, so please, everyone, submit them as we go through these, and we'll try to address as many as we can today. If we don't get to your question, we can certainly get back to you offline. So now let's just hear some questions from the audience. First, we have, what is the level of flexibility and adaptability of this octoscope-based test bed? Is it applicable to the test case requirements other than TR398?
So I can probably answer that pretty well from our perspective of how we use it in the lab. The test bed itself is incredibly flexible. You can always lay it out differently, connect it differently if you needed to. What we've tried to aim for in the way we've implemented it in the lab is to actually not require any physical changes as we roll through all the TR398 testing. So we can try to get that test bed to where we kind of get it to a well-controlled baseline that's very well understood, and then not be mucking with any of the things like the RF connectivity or the RF connections in it, because that just means that it's one more level of variability. One thing I can say about our test bed, and I probably should have actually hit on this earlier, if you'll let me flip back in slides a little bit. One of the things that we do have is we've got 3 different chambers here, and the chambers, while they do actually couple in and have that PAL6 located in 2 of the 3 chambers with the device under test in the 3rd, we do actually have the ability to put other devices in these chambers. So we can actually do things like put a real mobile phone in there, or a real station, and actually also using the same kind of near field antenna approach, see how that station collaborates or works or interops with the device. So we still have some level of flexibility in the way we implement the testing here in the lab to move beyond just purely the 398 requirements overall.
Great. I've got another question here. Does this testing include Wi-Fi 6?
Yes. So Wi-Fi 6 is essentially a trademarked name or kind of a brand name for the 802.11ax. You'll probably hear people referring to 6 or 6E, right? And so Wi-Fi 6 is essentially the 5 gigahertz version of 802.11ax, or the 2.4 and the 5 gigahertz version of 802.11ax. And then you'll see the 6E stuff starting to refer to actually moving to that 6 gigahertz availability, as a lot of the regulatory domains open up the availability of that spectrum to wireless unlicensed usage. And yes, we do the AX 5 gigahertz testing. The 6 gigahertz testing is something that's being looked at towards something like issue 3 development work today.
Our next question here from the audience is, what are the test cases with TR398?
So the full list of test cases, I think it's about 20 or 25 test cases, probably more than that if I was to explode them out into all their constituent parts, but they cover everything from like the RF performance. So looking at like a receiver sensitivity test, I would probably put that one in quotes actually, because it's not a proper receiver sensitivity test that you would do like in a conducted environment, but it is one that again takes into account the antennas and the performance of the DUT as it would kind of be deployed in the field. And then there's test cases looking at the maximum number of stations that can be connected to the device and what happens when those stations are joining or associating onto the Wi-Fi and disassociating. So there's cases that look at that. They look at that both from is how many can you actually have doing those operations, but then also from a long-term stability standpoint of what happens over a longer period of time when some stations are coming and going and other stations are just consuming traffic on the Wi-Fi, looking for kind of, bugs or performance issues there. You obviously have the couple of test cases I showed there with like the spatial consistency and the range versus throughput that are looking at to address some of those coverage areas or coverage interests. And then you have things like AP coexistence and stuff. So looking at what happens when you were to potentially have a wireless deployment in something like a multi-dwelling building or a place where you don't have that clean RF environment. So you're going to see RF signals that would be essentially alien to your own network, right? And like what those signals might be, partially overlapping, fully overlapping, or not overlapping at all on your Wi-Fi channel. And you want to make sure that your DUT is able to perform well in that case, because that's going to speak to how it's kind of bleeding signal into those other bands.
So we've got another question here. How does TR398 issue 2 define quality of experience for the consumer?
So quality experience from the from TR398's perspective, everything is about essentially measuring those throughputs, looking at the packet performances, looking at whether or not the device has any issues, stability issues, kind of overall for basically moving bits across that RF link, right? And so one of the things that I would, or maybe see if Mike has some input on, is translating that packet performance to the user experience, right? Because that the user experience, they don't care about bits moving across the wire. They're looking at it from how their device is actually behaving in their house.
Yeah, hey, thanks, Lincoln, for that handoff. And I think it's a good question. Number one, if we're able to understand how well the device performs, then we can directly relate that to understanding the feedback that we will get from some of the other parametric values that we collect in an implementation. Understanding how far away the devices are, understanding what their signal levels are. That, in conjunction with the performance of the device under test, really starts to define that quality of experience. Additionally, understanding that the performance of the device allows us to place devices in customer homes more effectively, again, directly relating back to that quality of experience that's achievable, including some proactive applications that would allow us to understand, hey, maybe you just don't have enough Wi-Fi in the home and you need additional extenders, because we're getting feedback saying, maybe most of your devices are really out of range with respect to the device performance. So understanding directly that device performance allows us to architect the topology in the home much better, which then again allows us to understand specifically that quality of experience. I hope that answers that question. Thank you very much, Lincoln.
Another question here. Do you envision expanding TR398 to include real-world performance characterization of device performance in dense environments such as MDUs?
Yeah, so I think that that's absolutely going to be part of where we're seeing the 398 issue 3 work progress to. Where the topic list there is actually pretty large. We're one of the first things we're kind of looking to do in an upcoming work session is to kind of pare that down or prioritize that work a little bit. Some of the things that are thrown out there, obviously, and if I was kind of unpack this question a little bit, there's dense RF environments. So that can either mean impinging alien signals, from other wireless deployments. It can mean, looking at how you deal with that scenario so you don't have a clean air RF channel to work with. It could also mean looking at how well your device is doing at like reporting something like the RSSI and like what is the accuracy level of that RSSI, which is one of the topics, for example, for 398 issue 3. Now, how does that relate to some of the other part of the question in terms of like, either algorithms or decision making or what I would say kind of closing the loop on that? Closing the loop on that automation is entirely dependent upon how good that data is going into those decision making algorithms. And so if you're inaccurate in like the RSSI, or if you're inaccurate in any of the performance monitoring and stuff like that, you would actually have issues from that. Where the steering or the decision making for that closed loop automation might actually make the wrong decision. So that's one of the things that is kind of that future looking arc in terms of not only just looking at the wireless performance, but also kind of understanding how this fits into those bigger picture type items. And then also, we do have some test cases there. I've kind of glossed over it and didn't dive through or make you guys read that full list of everything in 398 issue 3, but there is actually like a thing for auto channel selection in issue 2 as it exists today. So it's definitely moving in all of those directions overall.
Thank you.
Okay.
And just a
So,
reminder.
Dave,
Oh, go ahead, Mike.
no, I just wanted to jump in for a quick second. TR398 is an evolutionary document. Specifically, we started out looking at device performance, but I think the last question really drives where we need to get to is, once you understand device performance, then understanding device performance in a loaded environment, whether that be an MDU or whether that be in single family dwellings. We do have environmental issues that impact things. We have congestion and other Wi-Fi issues that will impact things. We have, off air, LTE or other type of interference that could potentially impact Wi-Fi. So the first step in really understanding device performance is really where we've been focusing on. But, as Lincoln had mentioned, moving into issue, 3 and above is really where we're going to start focusing on some of those real world over the air type of contention. What happens if type of issues. Does the device roam appropriately or choose the correct channel, and some of those other things. There's a ton of work in front of us, and probably at this point, a good invitation to listeners to get involved and really help us in defining those use cases that are important to them and their businesses. And back to you, Mara. Thanks.
Yeah, of course. Just have a couple more questions to answer, and then we can finish up. But I do have another question here. How does near field testing relate to performance in the far field? After all, user equipment isn't in the near field.
Right. So the near field antenna aspects, are really ensuring that we get the proper kind of RF behavior to the device without having to modify its RF performance overall. Obviously, the far field devices in a real deployment are going to be leveraging their own antennas, and then you're just going to be picking up the attenuation or the signal attenuation from normal path loss, whether it's free space radiation, et cetera, to the device, right? And so, it's not exactly obviously the way that the device is behaving in the real field, but when you're coupling that essentially near field antenna with a well-known, well-controlled antenna gain, to a well-known RF path with the controllable attenuator, that's basically the closest that we can get to doing that far field setup or that far field scenario condensed down to something that is not 100 meters worth of enclosed RF space or clean environment space.
How does the UNH-IOL testing process work? Like, how would a vendor request to get their device tested?
So UNH is a neutral test organization. We're working with vendors and operators from around the world. Any vendor can come and get engaged. The testing for 398 specifically requires 2 samples of the device overall. So those samples have to get shipped here to the lab. We would work with you to understand, what is the software configuration of the devices, what regulatory domain are they set up for, because that obviously sets some of those questions like the transmit power. Once we get that all sorted, we get you scheduled into the test schedule, and we would be able to run through the testing, whether it's 398 or working through you to do something more customized. Once that testing is complete, we develop up some detailed reports. Those capture kind of all of the data out of it, as well as some debug logs and anything else that would be applicable. Obviously, we're able to 398 mark pass-fail metrics on it, so how the device compared against the requirements outlined in the document. And then we provide that all directly back to the vendor that was scheduling the testing and sending their product in. And so from that point, you have kind of that third-party report. And depending on the outcomes of that testing, that report then might be something you could utilize as like a sales process or in your sales process to provide to your customers overall. As some of the operators are starting to now look towards asking for 398 results as they're kind of looking to the next generation of products that they're bringing into their networks, or even looking at some of the new firmware versions on products that they may already have in their networks.
We have time for just a couple more questions. How can network operators leverage TR398 testing for their deployments?
Yeah, Lincoln, maybe I'll take this one.
Yeah, absolutely, Mike. I was just going to say that.
So, one of the big challenges we have as an operator is, we get new devices in, we run them through rigorous testing internally, but a lot of that effort sometimes, drives a decent amount of churn between the vendor and the operator. So the way we see TR398 as really being very effective for us moving forward is it level sets device performance before we get the device. We understand what the device performance is in a standardized methodology, and it allows us to then, either as we get additional confidence with that vendor to take that at face value, or really use that information to leverage, our testing and results to make sure that what we see from a device performance is consistent with the UNH test results. That will drive an additional feedback loop back to UNH to really edify the test results and how we're moving forward from a consistency and value perspective. But again, more importantly, it gives us a real advantage in the deployment process as we understand that device performance, and it can really drive through our qualification and validation procedures much quicker. Lincoln, did you have anything to add?
No, I could not have said that better. And I'm excited to see service providers leveraging these results as they're looking to improve their networks and deploy the next generations of technology. And anything we can do to help take off that load and that burden from their labs allows them to really focus in on any of the parts and pieces that might be part of the differentiation of their deployments, right? So don't repeat the testing every single time for every single different operator. Use the same testing and be able to have that commonalities all across the broadband industry.
How are you planning to test OFDMA down and up?
So OFDMA down and up is actually something that's going into the issue 3 testing. As we're developing issue 2 testing, that was kind of right at the very bleeding edge and wasn't really well understood in terms of like what the performance metrics were going to be from, how it was going to be deployed and utilized, in scale. And so that, and then the other thing that kind of aligns to that too is also like multi-MIMO user, but in the uplink direction. I would kind of couple in and relate to that topic as being part of issue 3 work.
And our last question, when will validated products be in the market?
So we're looking for the first TR398 grade Wi-Fi products to be out in the market probably about this summer, started this summer. I think a number of the vendors that we're working with, a number of the product vendors are out there testing today and kind of getting everything tuned up to where they're hitting all the marks and have that nice green pass report everywhere.
And I apologize, we actually do have one more question. Do you see TR398 being coupled with Wi-Fi Alliance multi-AP certification to get full end-to-end performance characterization of a mesh Wi-Fi system?
So I might kick this one over to Mike, because I think that's actually kind of more on the how do the service providers look at kind of using kind of everything that's out there tools wise.
Yeah, so I think TR398 is complementary to Wi-Fi certification. Currently Wi-Fi certification doesn't define performance, and I believe that moving forward, the Broadband Forum and the Wi-Fi Alliance will be working together synergistically to really look at how do we not only get a Wi-Fi certified device, but how do we understand the performance of that Wi-Fi certified device. That is not in place today. But moving forward, I think it is action that we will definitely engage in because it's of everyone's benefit. Hey, it's a Wi-Fi certified device, fantastic. And hey, guess what? Here's the performance of the device. Wow, even better. So I think that's a forward-facing solution that we will actively engage in. Lincoln, any additional comments?
No, I think that's exactly right. I mean, they're complementary testing. They don't necessarily have direct overlap with it, and I think that both of them are important to kind of characterize the device's expected performance and operation in the field. So
yeah, the other point that I didn't answer is mesh performance, and I think as we look forward to TR398 issue 3 or potentially issue 4, it's going to be very important. We have a number of mesh solutions that are out there in the marketplace, both commercially and provided by service providers. Moving forward, we're going to need to understand how well that mesh performs inside the home, identifying not only backhaul performance, but front haul performance, steering performance, specific devices that may perform better or worse, depending on, some of the algorithms that some of the mobile device providers are starting to drive forward. So I think, there's a ton of work in front of us to really better understand mesh performance. And that is definitely on the target list for the TR398 moving forward. Thank you, Mara.
Great. Well, thank you, everyone. That sums up the Q&A portion of today's webinar. And I want to thank Lincoln and Mike again for explaining TR398 issue 2 wireless testing to us. Just want to make sure everyone knows how to get in contact with us. If you have any further questions, interested in learning more about testing, please be sure to visit us on our website. Again, just a reminder, we will have recorded version of today's webinar available for you. I will send that out, as well as the slides on our website for download. And in the essence of everyone's time, we will end today's webinar and hope you have a great rest of your day. On behalf of the IOL, we thank you again for joining us.
Thank you, everyone.
Thank you.